Lesson 9.2 is about parabolas. So let's start with the definition of a parabola. So that's the first sentence in your notes. A parabola is a curve consisting of all points in the coordinate plane that are the same distance from the focus and the directrix. The focus is a point, but the directrix is a line. So we have a point called the focus. We have a line called the directrix. And a parabola is every point that is the same distance from those two things. So it would look something like this. So no matter where you go on the parabola, let's say we choose this point. So anywhere you go on the parabola, the distance to the focus should equal the distance to the directrix. Now, that doesn't look equal because I drew it by hand. Alright, so any point you choose on the parabola, find the distance to the focus. It should equal the same as the distance to the directrix. Okay, here we have the equation of a parabola in standard form. The vertex of the parabola is h, k. So what you do is you take the opposite of what you see here. So if you see negative h, then the x-coordinate is positive h. But then you don't take the opposite there. You just keep it the same. Alright, I'll save the other stuff for later. Let's look at number 1. So if we want to graph that, first thing we need to do is find the vertex. So even though they don't ask for it, I'm going to write it out. So first thing I do, I look in the parentheses and I take the opposite. So it says minus 4, so I'm going to put positive 4. Then I look after the parentheses and there's a plus 3, so I keep that one the same. So for the x you do opposite, the y you keep it the same. Okay, let's plot the vertex on the graph. Okay, after you plot the vertex, the next thing you should do is identify the a value. So looking at the notes, the a value is in front of the parentheses. And so for our problem, we see that the a value is an invisible 1. So when the a value is 1, you're going to follow the odd number pattern. So the graph, because a is 1, it's going to go up 1 to the right 1 and up 1 to the left 1 from the vertex. After it goes up 1, from those two spots, it's going to go up 3 on both sides. And it's going to go out 1 again. And if we had room, well, what's the next odd number? The next odd number is 5. So it's just going to go up by odd numbers. Up 1, up 3, up 5, up 7. And every time you go up one of those numbers, you go out 1. Okay, for number 2, let's find the vertex. So the vertex opposite of positive 3 is negative 3. And we keep this number the same. Alright, let's go to negative 3, 4. Okay, in this problem, the a value is negative 2. So instead of going up 1, up 3, up 5, and so on, we're going to multiply all of those by negative 2. So the first movement would be down 2. Let's do that now. So I go down 2 and to the right 1, down 2 and to the left 1 from the vertex. Alright, the plus 3 will become a down 6. So now from there, from the last points we made, we're going to go down 6. And if we had room, we would go down 10 next, because 5 times negative 2 is negative 10. So the pattern of the parabola is just the odd numbers multiplied by the a value. For number 1, the a value is 1, so we just went up 1, up 3, up 5. For number 2, the a value is negative 2, so we just take the odd numbers and multiply them all by negative 2. Alright, now for numbers 3 and 4, we're just going to write the equation in standard form and identify a few things. Alright, so the first thing you want to do is put the two x terms in parentheses. Then I'm going to rewrite it. But after the 6x, I'm going to leave a gap. Alright. The reason we're going to leave that gap is we're going to complete the square. So, if you recall, the way you complete the square, find the b value. The b value is positive 6. So in this case, the b equals 6. Take the b value, divide it by 2, and then square the whole thing. So the number we really want is 9. So we're going to add a 9 here. And you can't just add a 9 to an equation, because then it's not balanced anymore. So to balance the equation, we could either add 9 to the other side, or you could subtract 9 on the same side. So I didn't want to add 9 to the other side because we want to keep y by itself. Alright, so why did we complete the square? The reason we completed the square is it created a perfect square trinomial there. So if we factor that, what was the value after we divided by 2? It was 3. So this is x plus 3 squared. Negative 4 minus 9 is negative 13. Alright, so that's the equation in standard form. Now they want the vertex. So we do the opposite of what we see in the parentheses. So plus 3 becomes negative 3. Then we keep the y the same. Alright, they also want the axis of symmetry. The axis of symmetry is just x equals, then you take the x coordinate from the vertex. And if you don't write x equals, then it's wrong, because we need to know that it's the vertical line. We're going to learn sideways parabolas soon, so you need to say whether it's x equals or y equals. Then we have to say whether the parabola opens up or down. So what you do is look at the a value. The a value was 1. Whenever the a value is positive, it opens up. Well, I should say, whenever the a value is positive, it opens up or to the right, but we haven't learned about sideways parabolas yet. Okay, number 4 is a little more challenging because the a value is not 1. Okay, so you start with parentheses around the x terms. And then on the next line, I want you to take out the a value. So I'm going to take out negative 2 from the two terms in the parentheses. So that would make x squared. And then if I take 16x and divide by negative 2, that would be negative 8x. Okay, then you leave your gap. And the negative 42, you just leave it alone on the outside. Okay, so now we're going to complete the square. So right now the b value is -8. So you want to take the b value, divide it by 2, which makes -4, and then square -4 makes +16. So a common mistake is that people want to write -16 after the -42. That would be incorrect because when we added 16 inside those parentheses, that 16 is actually going to get multiplied by -2. So when we put a +16 there, we really created a -32. So in order to undo that, we have to do the opposite and add 32. Okay, so now that we completed the square, we can factor the parentheses. So x squared minus 8x plus 16 is the same as x minus 4 squared. And then -42 and +32 make -10. Alright, so we have our equation in standard form, the vertex. We do opposite of the -4. Then we keep the -10 the same. They also want the axis of symmetry. So that's going to be x equals 4. And looking at the a value is -2. So this parabola opens down. Okay, so again, quickly reviewing the definition of a parabola. The parabola starts with a focus and a line called the directrix. And a parabola is every point that is the same distance from those two things. So anywhere you go on a parabola, the distance to the focus and the directrix, that distance is the same. Okay, now another thing we're going to introduce to you is how far is it from the vertex to the focus? That distance is 1 over 4a. The distance from the vertex to the directrix is also 1 over 4a. So that's sometimes called the DVF. The distance from vertex to focus is 1 over 4a. And technically, it's absolute value of 1 over 4a because distance can't be negative. Okay, so for number 5, they give you 2 coordinates and they want you to find the equation of the parabola and to graph the equation. So first thing I would do is graph what they give us. So the vertex is at 2, 3. The focus is at 2, 5. Okay, so I could already tell that this parabola opens up because parabolas always eat the focus and they turn away from the directrix. Remember that. Parabolas always eat the focus and they turn their back on the directrix. So I know this is going to open up. Alright, so the equation of a parabola is y equals a x minus h squared plus k. Now we already know h and k because the vertex has the coordinates h, k. So this is going to be y equals, and whenever you're writing the equation, the only letters that should be in your final answer are x and y. So you need to plug in for a, h, and k. So I'm going to write x minus 2 squared plus 3. And now for the equation, all we need is the a value. So remember that the DVF, or the distance from vertex to focus, is 1 over 4a. Looking at the graph, we can tell that the distance between these 2 points is 2. So because the distance between the vertex and the focus is 2, I can say that the DVF is 2. And now I solve for a. Multiply 4a to the other side, and you get 8a equals 1, so a equals 1/8. And after you solve for a, just double check if you want the positive or the negative value. And we want the positive value because we know it opens up. Right, so there's our equation, and now we're just going to graph it. Okay, so when your a value is a fraction, it's kind of difficult to graph. So another method to graph it involves using the latus rectum. So what is a latus rectum? A latus rectum is a line segment that has endpoints on the parabola, and it also goes through the focus. So a latus rectum is a line segment that goes through the focus and stops on the parabola. The length of the latus rectum is 4 times the distance from the vertex to focus. So we already established that that distance is 2. So the latus rectum in this case is going to be 4 times 2, or 8. So because I know the latus rectum is 8, I know that from the focus I can go 4 units to the left and 4 units to the right to make a total of 8. And I know that both of these points will be on my parabola. So now I'll make the parabola in red. So again, the latus rectum, we calculated that it was 8. It has to go the same length on both sides. So because it was 8, from the focus you go 4 to the left and 4 to the right. Okay, number 6. Let's start with graphing what they give us. So they give us the vertex is -5, 1. And now the directrix is the line y equals 4. So when it's y equals, it's a horizontal line. So there's our directrix. Okay, they don't give us the focus, but I know that from the vertex to the directrix is the same distance as vertex to the focus. I also know that this is going to open down because the parabola always turns away from the directrix. So if this distance between these two things, if you count it, you can count and see that that distance is 3. So then you can figure out that the focus is 3 units below the vertex. Okay, let's write the equation. We know it's going to be y equals a x minus h squared plus k. Y equals, we have not found a yet. So the x coordinate is -5, so we're going to do the opposite and write +5. Then we square the parentheses, and then we keep the y coordinate the same, +1. Okay, next we have to solve for the a value. Looking at the graph, the distance from vertex to focus is 3. So 1 over 4a equals 3. However, because it's opening down, I'm going to put -3 here. multiply 4a to the other side, and divide by -12. So we get a equals -1/12. So that will go in front of the parentheses. Alright, and then to graph this, I would use the latus rectum method. So the latus rectum equals 4 times the distance from the vertex to the focus. So 4 times 3. So the latus rectum is going to be 12 units long. The latus rectum always goes through the focus. So from the focus, we want to go 6 units to the right and 6 units to the left. We'll have to go off the graph a little bit. Now we could draw the parabola. Alright, that's it for the first half of 9.2.